Okay, everybody, it's time to review Dilution and yet another awesome video for you at home listening. This video is going to start with a little story, and this is a story that nobody knows this year because I haven't got to tell it. Normally, you'd have me standing in front of the classroom. It would probably be more entertaining, but here it goes. We're going to be talking about Dilution. Why is there a picture of Good Host Iced Tea, and why am I going to be talking about my roommate, Kale? His name is not Kale. I changed his name to protect his identity and stupidity. I don't know if Kale is still out there. I had a roommate in my first year of university who enjoyed Good Host Iced Tea. But he would make his Good Host Iced Tea by adding so little water to this gross mug. He would put his Good Host Iced Tea powder into this mug and a teeny tiny bit of water so that it made the Good Host Iced Tea into like this powdery, almost sticky icing sugar, and then he would eat it with a fork. If that doesn't terrify you, nothing should. So these problems are going to be about me diluting Good Host Iced Tea. Here we go. Okay, first problem. All right. Here is the first problem. To keep his roommate Kale from death by sugar, to keep his roommate Kale from getting death by sugar, sorry, I should be there, a typo there, Mr. Z diluted 10 mils of a 0.902 milliliter solution of Good Host Iced Tea to 1.8 liters. What is the final concentration? Okay, so dilution is C1V1 is equal to C2V2. That's our formula. And then if we write our toolbox over here, C1V1, C2V2. So what's the initial concentration? Okay, what's the initial concentration? Well, these are an initial concentration, our first system, 0.902 moles per liter. Okay, the volume is 10 milliliters. The question wants the final concentration, or C2. The volume final is 1.80 liters. Now, we need to convert that to milliliters to have similar units. So I'm just going to multiply that by 1,000. Now, I just got to grab my calculator over here from Friday. All right. So we're trying to solve for concentration of the second system. Let's divide both sides by V2 and plug our numbers in. The concentration of the first system is 0.92 moles per liter. The volume of the first system is 10 milliliters. The volume of the second system is 1,800 milliliters. And if you look, the milliliter on top cancels the milliliter on the bottom. We get, when we dilute it, should be a smaller number because the diluted concentration is small. I get 0.00501 moles per liter. Now, does that check out? Concentration of the first system should be bigger because a diluted concentration means there's less of it. Yep, that checks out 3 sig figs as well. 0.00501. All right, let's try another question. What volume of a 0.3 milliliter concentration must Mr. Z use to make a 2-liter dilute solution of Good Host Iced Tea at 0.05 moles per liter? Well, this is a dilution problem, so we're going to use the dilution formula. Let's set up our toolbox. Okay, so we're trying to make a dilute solution. So here is our dilute solution. The dilute solution is always the second system. So the concentration of the second system is 0.500 moles per liter. And the concentration of the first system, let's use proper sig figs, 0.3 moles per liter. Look at that. The concentration of the first system should be bigger. Now, the volume of the second system, it said, is 2 liters. Let's just turn that into milliliters. Because probably the original solution is going to have a really small volume. You can leave it in liters, and your answer is going to be in liters. So what we're trying to determine is how much of this concentrate do we need to use? So we're solving for the first volume. let's divide both sides by C1. So when we plug this into our calculators, we get 0.05 moles per liter times the volume of the second system, 2,000, over the concentration of the first system, 0.3 moles per liter. And if you look, the moles per liters will cancel. We're left with 0.05 times 2,000 divided by 0.3. Okay, so, okay, let me just double check that again. That's a little crazy. 0.05 times 2,000 divided by 0.3. Okay, so our concentration works out to, our volume works out to be 333 milliliters. So what does that mean? What did we just calculate? What does that mean? Well, let's say we had my roommate Brent's gross mug of the slurry of really concentrated Good House iced tea. So it's got 0.3 moles per liter. Now, I don't want him to die, so I'm going to dilute that into one of those, those big pitcher things, right? And that big pitcher has 2 liters in it. So in order to make that the proper concentration of 0.05, I have to take 333 milliliters out of it. I'm going to dump that into the big pitcher, and I'm going to fill it with water to the 2 liter mark. So what this 333 milliliters means is that is the amount that you take of the concentrate and then add water to it until you got to the final volume. Dilution is the addition of water to a concentrate to decrease the final concentration. So whenever you're finding the initial volume that you're using, remember that's how much you use, and then water will be added to that to get to the final volume. That's the review of dilution.